take and analyze using the methods we talked about in those first couple units. Okay, so we're going to talk about different sampling methods. We're going to talk about different types of studies that can be run. So where we do a sample survey, observational study, experiment, things like that. And we're going to talk about the collection process now. So not so much about what we do with the data, but then how do we just get it. And so the first thing, one of the most important topics in this particular unit is when you're given a scenario, being able to read through that scenario and picking out what is the population of interest. So who am I actually trying to find information about? Okay, so that's the first thing we have to identify is who am I looking for information on? And then, in most real-world scenarios, that population that I identify, that population that I want to know about, is usually a population that I cannot have access to the entire set of individuals. Maybe they're too far widespread, there's just too many to get the information from, it's going to cost too much, it's going to take too much time, whatever the case may be. So, I have a population I want to know about, but I can't access everybody. I can't go out and ask them every question or measure whatever I want to measure because it would just take too long. So we're going to use sampling methods to figure out what we can do in terms of estimating that actual value that we're looking for over that population. So a sample is what we're going to collect our data from. So we're going to talk about, like I said, different sampling methods that help us achieve a representative sample. The individuals that I select should more or less be the same makeup as the entire population of interest. That's going to be the goal. So I don't have access to my entire population, but I do have access to these individuals who are representative of that population. I can measure what it is I want to measure on that sample and then try to use that to either generalize to the larger population, or maybe we're looking for a cause and effect relationship between variables, whatever the case may be. But that's what we're looking at first. So that population, who do I want to know about? The sample, who did I get information on? So in that first example here, it says identify the population and sample in each of the scenarios. So the first couple homework problems were just about here's a scenario, identify the population, identify the sample. So in that first example, a furniture maker buys hardwood in large batches. The supplier is supposed to dry the wood before shipping so that it holds its size and shape. The furniture maker chooses 5 pieces of wood from each batch, tests their moisture content, and if any of the pieces exceeds 12% moisture, the entire batch is sent back. So when we're looking at this first scenario here, okay, there's a population of interest that the furniture maker wants to know information on, and there's a sample that he selects from that population to get a representative look at what that entire population would look like. So in this scenario, what would my population of interest be? Yeah, the entire batch of wood, right? So when he gets this shipment, he gets this large batch of wood. Now he's not going to sit there and test every single piece of wood, right? It's going to take too much time. For businesses, time is money. So instead, he randomly selects 5 from each batch. So there's my sample. And a lot of times in these types of situations, the sample is the easier piece to identify because they kind of tell you this is what they selected in terms of getting information from it. So my population would be the entire batch of wood shipped that day. And then the 5 pieces that he selects from each batch becomes the sample. And he uses the information found from those 5 pieces of wood to make a determination about the entire population. That's what the majority of this unit's going to be about. Okay? In that next example, it says each week the Gallup poll questions a sample of about 1,500 adult U.S. residents to determine national opinion on a wide variety of issues. Now, when I look at a situation like this, it's a little less descriptive. And in some instances, when we're identifying population, it can be a little bit subjective depending on kind of the context clues in the problem. So if I'm looking at this particular problem, did they tell me what my true population of interest is? So I kind of have to glean from what they told me about the sample. So that's like what I said, the samples sometimes are the place I want to start. Usually that's the easiest piece to pick out. So in this particular instance, the sample that they collected is what? The 1,500 adult U.S. residents, right? Now, as soon as they describe the sample to me, so that's what the sample is those 1,500 adult U.S. residents, in most instances then, the population of interest would simply be switching that 1,500 to the word all. So they're selecting 1,500 adult U.S. residents. We're trying to take that information and we're most likely trying to generalize that to all adult U.S. residents. So my population of interest would be all adult U.S. residents. The sample would be the 1,500. So sometimes they don't come out and tell you specifically what the pieces are. You have to use those context clues to kind of figure out what you need from them. But that's the first 3 or 4 problems of your homework. Here's a scenario. What's my population of interest? What's my sample? And that's probably the most important part of this data collection, is just understanding who we're trying to figure out information on, and then how am I going to go about doing that? What sample am I going to try to collect to get that information that I need? Okay. So sample surveys are what we're going to start off with. We're going to talk about all 3 types of studies today, but this is going to be kind of the first one we primarily focus on. And sample surveys are really just us going out and asking questions. So it'd be you going out, identifying a population of interest. You want to know something specific about that population. So you go and gather a sample. You ask the question to measure whatever it is you're looking to measure. And then you use that information from the sample to hopefully then generalize to that larger population of interest. So sample surveys are not very extravagant in the way they're set up. It's literally just, I have these questions I want answered. I have this population that I'm interested in. I'm going to go gather a sample from that population, measure the results of my questions, and then I compile the results. Okay, and that's really all that is. So the first thing we're going to talk about, or the first part of this unit we're going to focus on, is when we do these sample surveys, how do we get the correct samples? How do we figure out how to get the data that we need to measure what it is we're looking at and then be able to generalize to that larger population? When we conduct sample surveys, now this is review from the first unit. We talked about this right out of the gate, the first unit, this idea of statistics versus parameters. So we're just reviewing that topic here. When I collect information from a sample survey or from an observational study or from an experiment, as we're going to talk about in a little bit here, once I gather my information from my sample, I'm going to be measuring some response. And that response is going to be it's going to measure something where I'm going to get a value that's called a statistic. It's an estimate of that population value. So if I wanted to know what the average height of students at this high school was, I'm not going to go to all 18 or 1,900 students, measure their heights, and calculate the actual average. I would collect some type of sample of a much smaller number of students. I would measure their heights, and I would calculate the average for that sample. Now, that value that I calculate should estimate the true average height of students at the school. That's my statistic. So I collected a sample, I measured a value, and I'm going to use that value to estimate what the true population value would be. So that's a statistic, that's my estimate for that population value. And we use that to indicate our parameters. This was the other term we talked about back in Unit 1. The parameter is the value I actually want to know, which describes my entire population. So if I were to go gather all 1,900 students and measure every single height and calculate the mean, that would be my parameter. So I collected every single person in my population of interest. I calculated the value I was looking for. That's the true average height of students. So like we said, in most instances in the real world, I cannot collect the information from my entire population, which means my true parameter value is almost always going to be unknown. I don't know what the true average height for students at this school is, but I can go out and gather a sample easily enough, use that sample to calculate a statistic, which allows me then to estimate what that true value would be. If I do things correctly, and that's what this whole unit's about, if I gather that sample correctly, I should hopefully get a representative sample of the true population, which means my statistics should be fairly accurate. It should be pretty close to what that true average really would be. Okay, and that's kind of the whole idea of what we're dealing with here. Another piece of review then, with this parameter versus statistic idea, make sure we know the notation changes. If I'm talking about means, as a statistic from my sample, my mean notation is X bar. But if I actually calculate the true parameter, if I actually get access to my entire population and I calculate that true mean, then we use that Greek letter mu. For standard deviation, if it's a statistic, we use S. And if it's a parameter, we use the Greek notation, that lowercase sigma. So the notation changes from statistic to parameter as well. So that's something else we just want to be aware of when we're working through some of the problems here. So understanding that relationship between statistic and parameter, we're going to be calculating statistics and using those to estimate parameters. And again, that's kind of what this entire unit's going to be about. The other things that we're going to discuss as we go through the unit here, besides sample surveys, which is what we're going to start off by talking about. Okay, that's what the next 3 or 4 days worth of material is going to be. But then eventually we're going to get to observational studies and experiments. Observational studies are simply studies where individuals are observed, variables of interest are measured, but there are no attempts to influence responses that are being made. So in an observational study, all we're doing is we're identifying a sample of individuals that we want to gather information from, and we're simply observing. A retrospective observational study would be that I'm looking at information that's already been collected. So I identify a sample of individuals that I'm interested in. They already have whatever it is I'm interested in measured on them, so I go and collect that data from whatever source. And I use that information to put it together and create whatever it is I want from there. So that's retrospective. We're looking at stuff that's already been collected for us. We're just kind of putting it together in a different way. A prospective observational study is what happens when we actually observe things as they unfold. So conditions, behaviors, whatever it is I'm trying to measure is tracked in the present and into the future. So I identify the individuals that I want to know about, and I follow them over the course of a period of time. And over that course of the period of time, I measure and observe the pieces that I'm looking for. So I'm actually kind of gathering data as it happens rather than looking back at previous data already collected. Now, when we look at observational studies, okay, a lot of times we're interested in relationships between variables. So these observational studies, a lot of times that's what we're kind of our main goal is. It's not just about measuring a single value, it's looking at, okay, how do these things maybe relate? Now the problem with observational studies, because we're not doing anything in terms of controlling the environment or changing or imposing types of treatments is what we call them here in a second. When I look at observational study material and they want to know about cause and effect, observational studies cannot prove causation. This kind of goes back to what we just got done talking about in the last unit when I'm looking at scatter plots. Okay, we can see a linear relationship or a nonlinear relationship between variables, but that relationship does not imply a cause and effect relationship. There may be those lurking variables that are driving the relationship that we see. So something we didn't measure That's actually the reason that these variables react the way they do. So when we look at observational studies and they ask about the types of conclusions we can draw from them, we can take the information that we get from an observational study and we can generalize it to a larger population. So when I see the relationship that's in play, I can generalize that to my population. And we'll talk a lot more about this later in the unit, but for right now, I can take my observational study findings, I can generalize to a larger population, but I cannot imply cause and effect from what I've gathered. So the way we run those observational studies does not allow us to have that cause and effect relationship. So that's going to be important for your homework today. In an experiment, and experiments are something we're going to dive a lot more into in the second half of the unit. These are a lot more complex, a lot more involved. Okay, so we're just going to kind of introduce the basic idea of them right now. We're going to get a lot more in depth with these in the second half of the unit. But an experiment is a study that deliberately imposes treatments on the experimental units to measure their responses. So now in an experiment, we're actually going to be controlling the environment in such a way that we're going to be taking some of our individuals, imposing a certain treatment on them, taking a different group of individuals, imposing a treatment on them, and looking at how those different groups react to the different treatments. With experiments, because of the nature of those experiments, and like I said, we're going to talk much more about this in the second half of the unit, but because of the way we carry them out, these actually do allow us to prove causation. When I see the differences amongst the groups that I created, the different treatments that I opposed tell us a cause and effect relationship. So this group responded differently than this group, and we know it was because of this factor that we looked at. So for right now, just understanding the basic idea, observational studies, we just observe what's happening. Retrospective means we observe values that were already collected. Prospective means we observe as they happen. I can generalize those findings to a larger population. I cannot prove causation. Experiments, when they describe the situation, experiments are where we actually impose treatments. We're changing something deliberately for different groups of individuals to measure the differences in responses. So that deliberate treatment is what separates that observational study from an experiment. And when we do those experiments, then we can prove causation because of the nature of how we set it up. Okay, so it's important to kind of know those similarities and differences between these studies here. Like I said, we're going to get way more in depth with those experiments later on. So as we look at a couple examples here, researchers at Columbia University randomly selected 1,000 teenagers in the U.S. for a survey. According to an ABC News report about that research, it says teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. So the question is this an observational study or an experiment? And explain. So based on what they described here, okay, the main idea determining between an observational study and an experiment, were any treatments of any kind imposed? Was I creating separate groups of individuals under different conditions? No. It just says I randomly selected 1,000 teenagers and I asked them a question, right? So this is like a sample survey. This would be an observational study. So as we're looking at that then, if I'm looking at this, right? So they selected 1,000 teenagers in the U.S. for a survey. So because I randomly selected my sample, I would be able to take these findings and I can generalize them to a larger population, all teenagers in the U.S. But based on these findings, can I say that eating with your family will cause you to get better grades in school? So with an observational study, am I allowed to say that cause and effect relationship exists? No. So I can generalize to the larger population. This appears to be a trend that should follow. but there's no cause and effect implied here. When we look at the second example, does the pace of background music affect how fast people eat? So researchers at a university in Denmark asked volunteers to eat a piece of chocolate and rate it for taste and other features. They randomly assigned each volunteer to listen to either a slow-paced version or a fast-paced version of the same composition while eating. The researchers were secretly recording the amount of time it took the volunteers to finish the chocolate. And what they found at the end of the study was the average eating time was shorter for the group who listened to faster-paced music. So when we look at the description of this scenario here, would this be an observational study or an experiment? This one's an experiment, and how do I know? They changed something, right? They had some of the volunteers listen to slow-paced music, other volunteers listen to fast-paced music. So they imposed treatments on the individuals. So that's what tells me this is an experiment. Now, could I take these findings and generalize to a much larger population in this case? So for experiments, okay, here's where we got to pay attention to the wording. In experiments, we're dealing with volunteers. We're not randomly selecting our sample. So taking these findings and generalizing to a larger population doesn't work this time. In the observational study, it did because we randomly selected our sample. This time we're not. But can we, from these findings here, because we ran this experiment, can I say that the type of music being listened to did affect the pace or the time it took to eat the chocolate? Yes. So I can say that that change in music was what caused the change in eating time. Because of the way we set it up, because of the treatments we impose and things like that, we are able to do that cause and effect there. Okay, so you're going to have some questions in the homework kind of relating to those main ideas there. And so then here were the problems that you were supposed to kind of start looking at. So as far as today goes, I just want you to continue working on these.